Welcome to Pomodoro Joe for Tuesday, April 4th, 2023. Today we're doing LeetCode problem 2405, optimal partition of string. This is a medium problem. Given a string S, partition the string into one or more substrings such that the characters in each substring are unique. That is, no letter appears in a single substring more than once. Return the minimum number of substrings in such a partition. Note that each character should belong to exactly one substring in a partition. Okay, this actually seems pretty straightforward. We just need to go through and find where to partition our string into substrings such that they don't have duplicate characters. So we'll just start from the beginning and we'll go through, and as soon as we see a duplicate, well, then we chop off the beginning, that becomes a substring, and we'll keep going. Then as soon as we see a new duplicate, we chop off that part of the string and keep going. And yeah, we just keep going until we reach the end. That seems pretty straightforward, actually. All right, so let's put 25 minutes on the Pomodoro timer and we will get started. So what we'll do is start from the beginning of our string. We'll go character by character through our string, keeping track of which characters we've already seen. So once we find the duplicate character, then everything up to that character becomes a substring. We can chop it off and recurse on the rest of our string. That seems pretty straightforward. So we'll have some result. We'll set it equal to 1 to start with, because we'll always have at least one string. If it's the empty string, maybe not, but I don't think we can ever get to the empty string. So we'll start our result with 1. Now we need to keep track of all the characters we've seen so far. Now, whenever I have to do something like this, my go-to data structure is a set. Sets are really fast. You can add things to sets very quickly, and you can check to see if things are in the set very quickly. So this is kind of the perfect data structure for our needs. So I'll have scene characters, and that'll be an empty set to start with. Now we just have to go through our string, keeping track of where we are in the string and which characters we've seen. So let's just say for every index in length of our string. So for every index in the length of our string, I actually need to do range. There we go. So for every index in the range length of string, let's check the character at that index. So let's see, I'll do the negative case first. So if the character is not in our scene characters, well then we'll just add this character to our scene characters. Okay, so if our character is not in our scene characters, we will add this character to our scene characters. But if it is in our scene characters, well then everything up to this point becomes a substring. We don't need to keep track of what the substring is, we just need to keep track of how many there are. So at this point we can actually do a recursive call. So we'll return 1 because we just saw a substring, plus whatever our recursive call gives us. So now in the recursive call, we're ignoring the beginning part of our string, and we're just going from this current index to the end of the string. Now, at the very end, if we don't have any recursive calls in our for loop, then we will still need to return our result. So this should be it. All right, let's check this out. So we start a result equal to 1 because there's always one string. We have our set of scene characters. Now we'll just go for every index in our string. Check to see if the character at that index is in the scene characters. If it's not, we'll just add it. If it is in the scene characters, that means it's a duplicate. So we need to add 1. Well, we don't really add 1 to our result. We're just going to return 1 because we have one substring so far, plus whatever number of substrings we have for the rest of our string. All right, let's run this and see how we do. Okay, it works. Let's submit that, see if we pass. So we get a time limit exceeded. but we get 52 out of 59 test cases. So it means our algorithm is okay, it's just too slow. Now, I'm not too surprised by this. Recursive functions can be very slow and memory intensive, so I'm not completely shocked by this. So let's turn our recursive function into an iterative function. So how do we do this? Well, in this recursive call, all this is really doing is saying we're going to record that we have one substring, and then we're going to parse the rest of the string, starting with a new scene character set. So rather than doing a recursive call here, we could just add 1 to our result and clear out our scene characters. It's pretty much equivalent to this recursive call. Let's try that. So instead of doing this, we will just say result plus equals 1. So that's the equivalent of this 1 here. And then doing this recurse is kind of the equivalent of just clearing out our scene characters. Now we can set it to a new set if we want here, or we can call clear, either way. So let's do clear. So we've cleared our set of characters, but we need to add this current character to our set. So we still need to do this. Okay, so this should be equivalent. Previously, we were doing a recursive call, passing in the rest of the string, adding 1 to our result. So now we'll just add 1 to our result directly, clear out our set of characters, because in the recursive call, this would be reset to a new set. And then our scene characters will add this character, because in this case, we don't want to miss this character. All right, let's run that. Still works. Let's see if this can pass all our runtime checks. And we do pass. So we beat 38% for runtime and 90% for memory. Not too bad on the memory front. We could do better on the runtime. So let's see what we can do. First thing I'll do is remove this comment. It's not necessary. The second thing I'll do is we're adding this character either way. We could factor that out. Maybe. Well, let's do the simpler part. So previously, when we were doing the recursive call, we needed to keep track of our index so that we knew which part of the string to recurse on. Now we're not doing that recursive call. We're just going through the entire string. So we don't need to keep track of our index, and we can just grab our character directly out of the string. So now we can just say for every character in our string, and then every place we were indexing our string, we can just replace that with character. All right, that cleans things up quite a bit. Let's see if that works. Okay, let's see if this saves us anything. All right, that's a huge improvement. So that goes from 38% to 77%. We do drop a little bit in the memory, but that's all right. Let's see what else we can do. Let's see. If this is not in the characters, then we'll add it to characters. Otherwise, well, so this add happens either way. So what we can do here is just say, if it is in the characters, then we'll do this part. We'll add 1 to result, clear out our character set, and then either way, we're going to add our character to our set. All right. That cleans it up a little bit more. Let's see if that still works. Still works. Let's see if that gives us any improvement. It does. Now we're up to 88% for runtime, 47% for memory. Oh, 88% is so close. I think we can get to 90% just by making a few minor tweaks here. For one, changing some of these names. Now, I don't recommend doing this. Well, actually, let's see. Let's see if we can get a 90% without making our code unreadable. All right. So one thing we can try. We're currently using this set, and then we're clearing this set. We could, instead of clearing the set, we could just try setting this to a new set. It might take more memory, but it might give us a little boost in speed. Maybe. Or it might make our speed worse. I don't really know. Let's check it out. It actually drops our speed. Now we're down to 80%. So our clear worked better. Now, one thing we could try here too. Right now I'm using a set of characters. We could just change this to a string of characters. Now, theoretically, this should be slower. A set should be faster because a set should be using either a hashing mechanism or a tree internally to make the accesses very fast. Whereas this string will be a linear search every time we do a check. But Python's really good with strings. So let's try this. So instead of using a set, we'll just keep a string of all the characters we've seen so far. And then instead of calling clear, we can just reset this to an empty string. Now this may or may not work. And instead of saying add, we need to just essentially add this character to our string. It still works. Let's see if this saves us anything with the runtime. And we are beating 90%. All right, we're at 94% for runtime, 47% for memory. I should leave it there, but I kind of want to push the envelope on this one. So we are going back and we're going to change all these names to super short names, and we'll try to see if we can boost our score even higher just by making the parsing of our input script a little bit faster. So result becomes R. Scene characters becomes SC. All right, now that is super compact. Let's see if this will still work, and then we'll see if it saves us anything. And we are up to 98.8% for runtime and 90% for memory. That is a huge win. The code is super compact, it's clean, but it's also really hard to understand. Nobody who jumps in and just reads this code for the first time is going to know what's going on. So I do not recommend using this kind of code for production. You might use it in contests or coding competitions, but for a regular type job type coding, definitely don't use this type of coding. Okay, well that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.